I'm going to start talking about solving quadratic equations, and there's really 4 different ways that you can do that, and I have these listed here. Solved by the principle of square roots, solved by factoring, solved by completing the square, and solved by the quadratic formula. So there's going to be 4 different videos to watch about this, and this is going to be the first. And we're going to concentrate on the first step here, solved by the principles of square roots. So the first thing you want to get straight is to understand what a quadratic equation looks like. So a quadratic equation has an x squared term in it. Now it may have terms of a lower degree, and remember a degree is referring to the biggest exponent. So we may have an x, a term with an x in it. We may have a term without an x in it, but we're not going to have any exponent bigger than 2. So as long as the biggest exponent in your equation is a 2, you are dealing with a quadratic equation. So the method for solving quadratics that we're going to talk about during this video is using the principle of square roots. And this is kind of like a definition, I guess. It says for any real number k, if x squared equals k, then x is going to equal the square root of k, or x is going to equal the negative square root of k. So a couple things to keep in mind here. Just like any other equation, you want to get the variable you're solving for by itself on one side of the equation. You're going to do that by using opposite operations to move all other numbers and variables to the other side. So x squared and the square root, so like squaring and square roots are opposite operations. The other thing you want to keep in mind here is that you're actually getting 2 answers for these. One's a positive and one's a negative. Okay? Whatever the biggest degree of your equation is how many potential answers you have. Okay, so normally when we're just dealing with linear equations, we'd only get 1 answer. Okay, and if you think about that, all linear equations, all equations that you're used to solving, the exponent was 1. You got 1 answer. Now we're going to be dealing with squareds, quadratics, and so now we're going to have potentially 2 answers. If we're dealing with a cubic, we could potentially have 3 answers. A quartic, which is a degree of 4, the exponent is 4, you could have potentially 4 answers. Now I say potentially because you could have repeated answers. So there's nothing to say that both of our answers aren't 1. Okay, so this is something that you want to keep in mind from here on out. So using the principle of square roots to solve quadratic equations is fairly limited. Most quadratics that you're going to see have 3 terms in them. We call them trinomials. And for instance, this first one that I have written down, it is a quadratic because the biggest exponent is a 2. And you notice that we have 3 total terms in them. Now since this is part of this equation, this term here, where x is to the first power, we cannot use the principle of square roots. Okay? So we can only use the principle of square roots in this kind of situation where our term with the variable is squared and our other term has no variable in it. Okay? The other 3 options at the beginning of this video would be, you would have to use those to solve a quadratic equation of this form. Okay, but once you have equation set up in this way where we have just the x squared term equaling some number, all we're going to do is use the idea that the opposite operation is to take the square root. And when you take a square root, it's similar to adding and subtracting in that you have to do it to both sides of the equation. Okay, so we're going to take the square root of both of these. Remember, our principle of square roots say that x is going to equal the positive square root of 25, and or it's also going to equal the negative square root of 25. Now, of course, the square root of 25 is 5, and then this will be negative 5. So our two answers are 5 and negative 5. And you can always check these by plugging them back in. 5 squared is 25, and negative 5 squared, negative 5 times negative 5 is also 25. Okay, this statement is just a good rule of thumb. It's not absolutely necessary, but it just makes your life much, much easier. So any number, any coefficient, any number by itself, you want to move to the opposite side of the equation before you take the square root. And so in this case, we're going to end up dividing both sides by 3 first. And we have x squared equaling 2. We're going to take the square root of both sides, and we're going to have x equaling the square root of 2 or the negative square root of 2. And don't be changing these into decimals. Those don't do you any good. We want the actual number. Okay? If you take a square root of 2 and round it, you're just doing an estimation. Square root of 2 or the negative square root of 2 is a much better answer. Now you're allowed to answer it like this: positive and negative square root of 2. But make sure you have both answers. So I'm going to do 2 more examples where we talk about solving quadratics by using the principle of square roots. Again, you want to get every number you can onto the other side, so we're going to start by subtracting 2. Get negative 5x squared equaling negative 2. Then we're going to divide by negative 5. X squared equals positive 2/5. And now we're going to take the square root of both sides. Make sure you get both the positive and the negative answer. And again, it's very easy just to write plus or minus square root of 2/5. Now this answer is not simplified, and there's something called rationalizing the denominator, which we're going to get into eventually. But as of right now, you can leave this answer as is. You're not really supposed to have a square root in a denominator like we do here, and in the long run you're going to want to change that. So the real answer would end up looking like plus or minus the square root of 10 over 5. And if you plug both of these things into your calculator, you would see that it would estimate it to be the same thing. Square root of 2/5 and the square root of 10 divided by 5. But again, don't worry about that as of right now. This is a perfectly fine answer to have. So this will be the final example, and we're going to just start off just like we've done on the last couple by subtracting the 9 over, because we would like to get all numbers that we can to the other side. We're going to divide by 4, and we have x squared equaling negative 9 over 4. Okay, we're going to take the square root of both of these sides, and we'd have x equaling plus or minus the square root of negative 9 over 4. Now remember, when you take the square root of a negative number, you're introducing this imaginary number into the whole situation. So really what this is x equaling plus or minus I times the square root of 9 over 4. Square root of 9 is 3. The square root of 4 is 2. So it's going to be x equals plus or minus 3 halves I.